Assalamualaikum and a very pleasant day to all. My name is Muhammad Firdaus bin Hashim from 4 BMMA Section 2 SOC 1. Today I will be presenting about my final year project on a design of smart anti-theft motorcycle mechanical lock using a part method. Next slide. Chapter 1. Introduction. The number of motorcycle robberies reported today is more than at any other time in recent history. Motorcycles contribute significantly to the industry. Then there are motorcycles which are also widely used as a mode of transportation. Furthermore, statistics about stolen motorcycle problem in Malaysia is under control, even though the number of motorcycle theft is falling year by year. Motorcycle theft continue to account for the majority instance across all vehicle categories. Next slide. Problem statement. The theft of motorcycle is becoming more common these days. In 2017, police received 31,577 reports of stolen motorbike. It's an average of 87 bikes stolen every day in Malaysia. Motorcycle theft is common because there are not enough security lock for motorcycles that provide adequate protection. Thus, a high-security lock for motorcycle was designed. As a result, it's tough to locate the finest locked motorcycle on the market with great security, which is one of the main reasons why motorcycles are still simple to steal. But it's just a sting. That is why my project is to come up with a solution to this problem. To assure people or customers that their motorcycle is not easily stolen, the anti-theft locks system must be of high performance and security. Next slide. For the common problem, first is easy to steal. Motorcycle theft is a crime on the rise, especially the theft of motorcycle that doesn't have high safety due to the fact they can be stolen in seconds. Second, law of safety. A handle lock is very easy to defeat. Thieves just need to kick the bus and its brakes. A typical technique, especially in a busy city, is to snap the steering lock, then push the motorcycle away. Next slide. For my project objective, first, by the end of this project, a smart anti-theft motorcycle lock system will be designed using a path method. Second, by the end of this project, a strength analysis will be done on the prototype CAD model using finite element analysis in SimSolid software. Third, by the end of this project, a 3D prototype of a smart anti-theft motorcycle lock system will be developed using 3D printing. Next slide. Chapter 2, Literature Review. A review of literature review relevant to the present study comprising types of a lock system in market to conduct the development of the best locking system that connect the front and rear tires. Inspiration came from the frame lock that used to lock the bicycle's tires. The types of lock is frame lock and the material is used steel. For the pros, first, lightweight and easy to use to safeguard your bike against unauthorized users. Then, relatively light and have a stiff shape. For the cons, depending on their size and flexibility, they might be difficult to loop around non-standard or large objects. Next slide. Chapter 3. Methodologies. The flowchart at the right-hand side shows the graphical presentation to show the methodology for this project. The methodology of this project was discussed the process of development of anti-theft motorcycle lock system for motorcycle. Firstly, the focus of this project was on gathering as much design input from various sources, then doing some research about the design that will get solve this problem statement. Next, the process is continued with doing the design project by using Autodesk SolidWorks 2019 software. Then, the design project must use the finite element analysis to find and see the strength of the body of self-anti-theft lock for motorcycle. Lastly, the process of develop 3D prototype will be proceed by suitable material using 3D printer. Next slide. Chapter 4. Prototype development process. The design concept that were generated at the concept design stage will go to the concept evaluation stage to evaluate and choose the most suitable design to develop the new prototype. To choose the perfect design, there are three design concepts that has been created to research by using a part method. The evaluation criteria consists of security level, easy apply, complexity, strength, weight, durability, and installation time. Next slide. Design process. CAD model for ATLS products consists of body rod for ATLS and tire lock for front and rear tire. Figure shows the 3D design of the body part that was drawn in SolidWorks 2019 software. For the road body for ATLS is taking inspiration from a few available designs discovered through a literature review and market survey. And for the lock for front and rear tire, the 3D model was developed according to the actual function of the frame lock as shown in literature review as benchmark used in this project. However, certain adjustments were performed using the different dimensions and parameters in accordance with the tire size guidelines for motorcycles with low side. Next slide. For the full assembly of prototype, the figure shows an exploded representation of the prototype complete with bill of material. The item consists from 1 until 7 items. For the item number 1 until number 5 is a body rod of the LTLS, and the item number 6 is a connector between the body rod and the lock tire for the LTLS, and the last item is lock tire for front and a rear tire for motorcycle. Next slide. For the finite element analysis process, from the design analysis process will be used into the CAD model to see the strength of the body rod ATLS strength using SimSolid simulation software, and the result were displayed in terms of maximum displacement magnitude, maximum von Mistress, and minimum safety factor. If viewed from the side, the rod body are supported at one end that which will hit the motorcycle engine cover, and at the joint between the tire lock and the tire rim was given the force of the moment that brings the motorcycle forward. Next slide. And the getting result for the maximum von Mistress experienced by the body rod of ATLS was 1.1575 times 10 power of 6 Pascal and located on the part that is stuck to the engine cover. Second, in terms of maximum displacement magnitude, the ATLS body rod experienced a maximum displacement of 2.2488 mm. The maximum displacement occurred at the rear end of the ATLS tire lock. As for the minimum safety factor, the ratio minimum safety factor experienced by the ATLS body rod was analyzed to be 2.2615. A factor of safety of greater than 2 represents how much the stress is within the allowable limit. Next slide. For the developed 3D prototype, the figure shows the isometric projection of the 3D prototype of a smart anti-theft motorcycle lock system that already developed using 3D printing. From the top view for the top left, front view for the bottom left, side view for bottom right, and the isometric view top right. Next slide. Chapter 5. Conclusion. For the first objective, by the end of this project, a smart anti-theft motorcycle lock system will be designed using a PUB method. The result getting from the project, the prototype development approach used in this project resulted in a well-functioning prototype that met all the project's requirements. The second objective, by the end of this project, a strength analysis will be done on the prototype CAD model using finite element analysis in SimSolid software. The result from getting the project discovered that the application of an appropriate finite element method for the body rod of ATLS has proven that it can provide a high security system for motorcycles, provided that the prototype dimension and materials are appropriate. For the last objective, by the end of this project, a 3D prototype of a smart anti-theft motorcycle lock system will be developed using 3D printing. The result is the 3D printing technology was used to demonstrate the real design of the ATLS system. Next slide. Before I end my presentation, I would like to say that I am very grateful to have a great supervisor and a supportive members around me that give me a tremendous support for me to complete my research in my project. Thank you. for watching my presentation video until the end, and have a nice day ahead and stay safe everyone. That's all for me. Thank you.